Here we are in section 1.3, exercises part C, with the solutions to numbers 19 through 27. It's going to be some long division here. Might be a little bit tough, but we can do this. So 19, this says change into a decimal, and we do that by division, 1/20th. So we have 1 divided by 20. We're going to have to put some zeros there to make that work. So 20 goes into 1? No, it does not. Does 20 go into 10? Nope, it does not. Does 20 go into 100? Yeah, it does. 20 goes into 100 5 times. 5 times 20 is indeed 100. When we subtract it at 0, it comes out evenly. So that's it. We don't even need these other zeros. 0.05. Let's double check our answer. 0.05 is indeed the answer. Good. Number 20, 4/9. So we're going to take 4 divided by 9. Put some zeros out here so we can see what's going on. Does 9 go into 4? It does not. Put the decimal straight above. 9 going into 40 is 4. 4 times 9 is 36. Subtract 40 minus 36 is 4. Bring down this 0 right here, and we get 9 goes into 40. Hey, we did that before. It's a 4. 4 times 9 is 36. Subtract those and we get a 4, and we realize, hey, look what's going on here. 0.44, we're going to get a 40 again, and it's going to keep going forever. So that means it is 0.4, and that repeats that pattern. So we put a bar over it like that. 0.4 repeater. And yes, indeed, that is what it is, 0.4 repeater. 21, 2/3. So we're going to take 2 divided by 3. Put some zeros out here. 3 goes into 2. It does not. Put a decimal up there. If you want to put a 0 there, that's fine. 3 goes into 20. Yes, it does. 6 times. 6 times 3 is 18. Subtract, and we get a 2. Bring down that 0 there. 3 goes into 20. How many times? 6. Hey, that was what we had before. 6 times 3 is 18. Subtract, we get a 2. Bring down a 0. We're going to keep going 20, 20, 20. So this is 0.66666 on forever. Do 0.6 with a bar over it. 0.6 repeater. Let's double check our answer. Yes, indeed, that is correct. Good. So let's try the next set. Number 22, 8 into 434. Alrighty, let's see if we can do this one. 8 goes into 43 5 times. 5 times 8 is 40. Subtract, and we get 43 minus 40 is 3. Bring down this 4. 8 goes into 34 how many times? Goes into it 4 times. 4 times 8 is 32. So when we subtract, we get a 2 there. So this could be 54 remainder 2, or 54 and 2/8. We could write that if it was a fraction, but it looks like this is mostly going to be decimal stuff. So that is the correct answer if we reduce that. 2/8 is the same as 1/4. So 54 and 1/4 could be a way of writing the answer, but let's put some zeros out here and see what it is as a decimal. So we drop down a 0 here. 8 goes into 20 2 times. 2 times 8 is 16. Subtract 20 minus 16 is 4. Drop down a 0. 8 goes into 40 5 times exactly. So 5 times 8 is 40. Subtract it and we get a 0. Whew, some of those get pretty long. 54.25, and yeah, 0.25 is the same as 1/4. So that's our answer right there. Let's double check and make sure that's correct. Yes, 54.25. Good. Number 23, 6 into 185. 6 goes into 18 3 times. 3 times 6 is 18. Subtract it. Hey, that went in evenly, but we still have this 5 to deal with. 6 goes into 5. It doesn't. So that's a 0. Multiply. 0 times 6 is 0. 5 minus 0 is 5. And so you could write down 30 and 5/6 as an answer. Let's keep going to see what the decimal is. I don't know how many we'll need, but drop down the 0 and you keep going. 6 goes into 50. How many times? 7, 8, 9? No, 9 is 54. 9 times 6 is 54. That's too big. 8. 8 times 6 is 48. Subtract and you get a 2. 0. Bringing down that guy, I think is the one we're on. 6 into 20 is 3. 3 times 6 is 18. When we subtract, we get a 2. Bring down that last 0. 6 goes into 20, another 3, and it will repeat this pattern. So we put a bar just over the 3. It's not repeating 838383. It's 30.83 with a bar over it right there. Let's double check our answer. 30.83 with a bar just over the 3. That's great. Ooh, number 24, 14. Ooh, I don't know those times tables nearly as well. Let's see how we do on this one. 14 goes into 6. Nope, 14 goes into 68. Yeah, 14 will go into 68. Let me see. 3 times 14 is 42. 4 times 14 is 56. 5 times 14 is 70, so that's too big. So 4 times 14 is 56. Subtract it and we get 12. And the 9 drops down here. 14 into 129. Let me see. 14 times 8 is 112. 14 times 9 is 126. So that looks like what we're going to do. 9 times 14 is 126. Subtract it and we get a 3. So we could write the answer as 49 and 3/14. Alrighty, that's one way to write it, but again, this is in decimals, so it probably has decimals as the answer. So let's keep going with the zeros. We can just keep doing this all day. Drop down the 0 there. 14 goes into 30 2 times. 2 times 14 is 28. 2. Okay, so now we can drop down that 0. 14 goes into 20 1 time. 1 times 14 is 14. Subtract and we get 20 minus 14 is 6. Bring down another 0. 14 goes into 60. Ooh, let me see. 4 times it is 56. 5 times is too big. So a 4 right there. Good. 4 times 14 is 56. That leaves us with a 4. Add another 0 if we want to keep going. 14 goes into 40. 3 times is too big. That's a 2. So we'd get 28, and we could keep going dot, 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 dot. I think that's good enough to stop. Now, if you go out 4 decimal places, that means you can actually write officially the answer as 3 decimal places, because you'll know this guy will cause that guy to either round up or remain where he is. So this is 49.214. Now, many of you may ask the question, how do I know when to stop? Why couldn't I just write 49.21? You could. Let's double check this answer. It says 49.214 dot, dot, dot. It keeps going on. And it says note on decimal places in the answers. For most of the problems in the textbook, the number of decimals of the answer is not specifically requested. Now, if it told us to, definitely. If it said round to the nearest hundredth, then we'd have to do 49.21. But if you or others chose to round at a different place value, it's perfectly fine. So if you wanted to do just 1 or 2 decimal places, that's okay. That's all right. All right, let's do these last 3, 25, 26, 27. But we've got to erase some of these numbers first. That's better. Okay, these guys right here, 0.02 into 56.347. This is a decimal. That's going to be hard to do all the time. So let's move this decimal 1, 2 places. 1, 2 places. So we actually have 2 going into 5634.7. There we go. That's better. Now we know the 2 times table, so we can do this better. 2 goes into 5 twice. 2 times 2 is 4. Subtract, we get 1. Bring down the 6. 2 goes into 16 8 times. 8 times 2 is 16. Subtract, and we get a 0. Bring down the 3. 2 goes into 3 1 time. 1 times 2 is 2. Subtract that, and we get a 1. Bring down the 4. 2 goes into 14 7 times. So 7 times 2 is 14. Subtract, we get a 0. Bring down the 7. 2 goes into 7 3 times. 3 times 2 is 6. Subtract, and we get a 1. Uh-oh, we're going to need another decimal place out here. And that's a 0 down there. And 2 goes into 10 5 times exactly. Oh, lucky that didn't repeat like this guy did, or keep going on forever. 0.35, 2,817.35. Let's look at that. Yep, and that one is an exact one. All right, number 26. Let's see if we can not make it quite so long here. Again, this is a decimal. So we've got to move this guy one place over here, and this decimal that's right here behind the 3 has to go one more place, so we'll put a 0 in there. So really it's 6 goes into 5530. 6 goes into 5, it does not. 6 goes into 55 9 times. 9 times 6 is 54. When we subtract those, we get a 1. Drop down the 3. 6 goes into 13 2 times. 2 times 6 is 12. Subtract, and we get a 1. Bring down that 0. 6 goes into 10. Notice we're using our multiplication tables so much. It's a good thing we studied and memorized those. If you haven't yet, it's a good chance to remind yourself that it needs to be done. 6 goes into 10 one time. 1 times 6 is 6. And 10 minus 6 is 4. So this could be 921 and 4/6, but since it started in decimals, we'll keep the answer in decimals. Bring down a 0. 6 into 40 is 6. 6 times 6 is 36. Subtract, and we get a 4. Drop down another 0. 6 goes into 40 6 times again. And we're going to repeat. So it'll be 666. So the answer will be 921.6 repeater. And again, we move the decimals at the beginning, but it gives us the exact same answer. These two problems have the same answer, so the answer is 921.6 repeater. And number 27. Let's finish that guy off. This is 0.31 into 175.12. So we're going to go 1, 2 places, 1, 2 places. So the problem that we're really going to do is 31 into 175, 1, 2. So actually 17,512. Ooh, 31 goes into 17. It doesn't. 31 goes into 175. I'm not so sure. So I'm going to have to estimate. 30 goes into 175, like 3 goes into 17. I'd say 5 times. Let's try it and see if we got too far away. 5 times 1 is 5. 5 times 30 is 150. So 155. When we subtract that, we get a 20. It's not until this number comes out, it's not bigger than 31, and we were able to stay under 175 that we know, hey, we got the right thing. So 5 times 31 is 155. Subtracted them, and we got 20. Bring down the 1. All right, I'm going to have to estimate again. 30 going into 200 roughly. 3 into 20, that's a 6. So 6 times 1 is 6. 6 times 3 is 18. And now we subtract. Oh, shoot. We're going to have to borrow on this guy. Can't borrow from a 0, so I have to make that a 1, make that a 10, make that a 9, make that an 11. Wow. 11 minus 6 is 5. 9 minus 8 is 1. 1 minus 1 is 0. So we bring down the 2. All right, so we're at 152. If I were to estimate, I'd say 3 goes into this 5 times. But we already tried that, and we got 155 before. So that'll be too big. So we'll only be able to go in here 4 times. 4 times that is 124. When we subtract that, we get 28, I think is. Let's borrow and let's make sure we do that right. That will go down to a 4, and that'll be a 12. 12 minus 4 is 8, 4 minus 2 is 2, and 1 minus 1 is 0. So we could write the answer as 564 and 28/31. So there's the fraction version of the answer if we stopped right there, but they gave it to us in decimals, so let's keep going. At least a couple of decimal places. So we bring down a 0. 31 goes into 280. 3 goes into 28 9 times, so let's do a 9 here. 9 times 31 is 279. Wow. 280 minus 279 is 1. Bring down the other 0. That's a 0 right there. Holy cow. So then 0 times 31 is 0. Subtract and we'll get that 10. So let's bring down another 0 and see what we get. 31 goes into 100 3 times. And so, well, is that good enough to stop at? Yeah, let's go ahead and stop there. So we're going to write 564.90. This one tells us it'll round to there, so 0.9. I'll stop right there and let's double check our answer. 564.903. So they kept going. But again, if we choose to round it a different place value, it's all right. That's okay. That's all right. And if it doesn't say where the decimal place should be rounded to, then you're welcome to stop places. So this is perfectly legitimate. We're more interested that you're understanding the process of long division.